Hello, Intro to Algebra students. Today at Independent you should be taking notes for 8.8. So you should have your systems of linear equations notes out. The top of the page looks like this. And we're going to get our notes for the next section. So you're graphing and solving a system of linear equations is our goal for this section. And so we need to know what a system of linear equations is. So a system of linear equations consists of two or more linear equations with the same variable. So the difference here is we're going to be looking at two or more linear equations together. So far we focused on one equation at a time. This is going to be two or more equations at a time. Our solution to this linear system in two variables will be an ordered pair. We already have looked at solutions being ordered pairs, and this will be an ordered pair that is the solution of each equation. So it will be an ordered pair that has to satisfy both or however many equations you have. So it has to be true for all of them. So in example 1, we're going to solve the system of linear equations. And one of the first ways we're going to look at solving is graphing. So of course we have to graph the equations. So I'm going to start with the first equation. Y is equal to x minus 3. Now you should know that that tells you that the y-intercept is negative 3. So on my graph, I'm going to put a dot at negative 3. Then that tells me the slope is 1, and that should tell you to go up 1 over 1 to get your next ordered pair. And we can continue to do that up 1 over 1 to get the next ordered pair as we go through. And then we can sketch our line. Get a few ordered pairs in there, you can sketch the line. Then we'll graph the next line. I'll graph this line in blue. So that line has a y-intercept of positive 3. So I put my starting point at positive 3. And the slope of negative 1/5 should tell you to go down 1 over 5. So I'm going to go down 1 over 5 before I put my next dot. I can continue that process, or I can just draw my line through the 2 points. The point of intersection is the spot that the graphs overlap. That apparent point of intersection is at 5, 2. We want to verify that 5, 2 is the solution of the system by substituting in 5 for x and 2 for y in each equation. So you can see that we write both equations. So in the first equation, again, I want to substitute in 5 for x and 2 for y. I get 2 is equal to 2. That's good. That solution, that ordered pair 5, 2 works in equation 1. But in order to be a solution of a system, it needs to work in both equations. So let's check it in the second equation. Again, I want to substitute 2 for y, and I want to substitute 5 for x. It's a times sign there. And so I get 2 is equal to, and again, I get 2. So it works in both equations. That means the solution to this system is 5, 2, because the ordered pair 5, 2 works in both equations. In example 2, we'll look at solving a linear system when there's no solution. So we have two equations. Again, we want to graph the equations. So let's graph them. The first equation has a y-intercept of negative 2. So we're going to put our y-intercept at negative 2. And the slope tells you to go down 3 over 1. Down 3 over 1. So that gives me this graph. To graph the second equation, I have a y-intercept of 3, and again the slope is negative 3. So that's down 3 over 1. Because the lines have the same slope, the lines are parallel. The graphs appear to be parallel lines. You can confirm that the lines are parallel by observing from the equations that they have the same slope. And we learned in section 8.5 that parallel lines have the same slope. Their slope is negative 3. They do have different y-intercepts. Their y-intercepts are negative 2 and negative 3. Because parallel lines do not intersect, the linear system has no solution. Because the solution would be where they meet, and since those parallel lines never meet, there is no solution. In example 3, we're going to look at a linear system with many solutions. First, we want to graph the solutions, but they're not in graphing form. They're not in slope-intercept form. So we want to solve them for slope-intercept form first. So looking at equation 1, we're going to subtract 2x from both sides. And we get y is equal to negative 2x plus 4. When we have it in slope-intercept form, we can graph it. The y-intercept is at 4, and the slope is negative 2. So that tells us to go down 2 over 1, down 2 over 1. And we can connect our dots. Then we go back to the second equation. We also need to put that into slope-intercept form. So we would start by adding 6x to both sides. That's going to give me negative 3y is equal to 6x plus 12. But the y's not by itself yet. We have one more step. We need to divide everything by negative 3. And we get y is equal to negative 2x plus 4. Now we can graph it. That y-intercept is at 4. And the slope is down 2 over 1, down 2 over 1. Hopefully you can see that those lines are overlapping because they are the same line. The slope-intercept form of the equations 1 or 2 are identical. So the graphs of the equations are the same line. Because the graphs have infinitely many points of intersection, the system has infinitely many solutions. So any point on the line with that same equation would represent a solution to that system. Let's review with the checkpoint. We want to solve by graphing. First, we graph one of the equations. Y equals negative x plus 3 is a y-intercept at 3 and a slope of negative 1, down 1 over 1, down 1 over 1. Then we graph the second equation. That equation has a y-intercept of negative 1 and a slope of 1/3, which tells you to go up 1 over 3. The solution is the meeting point of those two lines. And so that is the ordered pair 3, 0. To be sure, we would plug in 3, 0, 3 for x and 0 for y in each equation and make sure it works. For number 2 in the checkpoint, we don't have them in slope-intercept form yet. So let's take a moment to put the equations into slope-intercept form. So for the first equation, we want to subtract 5x from both sides. We get y is equal to negative 5x plus negative 3. That lets us graph. We have a y-intercept at negative 3 and a slope of negative 5. Now that would tell me to go down 5 over 1, but I can't go down 5 on my graph and fit it. So that means I'm going to go up 5 and to the right 1. Remember, I just reverse things when I need to go backwards to fit the graph on the picture. And draw my line. Now I need to put the other equation into slope-intercept form. Subtract 10x from both sides. You end up with 2y is equal to negative 10x plus 8. And hopefully you know your next step is divide everything by 2. You should get y is equal to negative 5x plus 4. So that line has a y-intercept of 4 and a slope of negative 5. Down 5 over 1. Those lines appear to be parallel. I double check and I find that they have the same slope. So there is no solution. In example 4, we're going to apply what we know about systems to a word problem. An ecologist is studying the population of 2 types of fish in the lake. We want to use the information in the table to predict when the population of the 2 types of fish will be the same. That's the meeting point of the 2 solutions, of the 2 equations, the ordered pair where the 2 lines would meet. So let y be the number of fish after x years, and we want to write a linear system. So that's giving us our starting point. That is our y-intercept. It's also giving us our change. That is our slope. Remember that slope is rate of change. So for population A, we have y is equal to, and the change is that it's going down 25 per year, and the population starts at 340. For fish type B, y is equal to, and the rate of change is 15 per year, and the population starts at 180. We're looking at the meeting point, so we want to solve the system. Now it says to use a graphing calculator to graph the equations. We'll take a look at this together when we go over our notes in class. The point where these meet is at 240. What I'd like you to think about is what that means. The number of fish will be the same after how many years? When the population of each fish will be what? The number of fish will be the same after 4 years. That's your x value. When the population of both fish types will be at 240. So the idea is that the ordered pair is the meeting point of the two equations, where the two equations would have that same ordered pair and the same solution. So you should have all your notes for this section. We've now looked at several things. We looked at the systems of equations being a solution to two or more equations. And we saw that a system could have one solution, a system could have no solutions, or a system could have many solutions. And then we applied it to a word problem. Bring any questions you have to your teacher when you go over the notes.